Okay, so the next thing that we have is called standard deviation. Standard deviation. So what that means is that, let's see what that means. In the calculation of variance, we find that the units of individual observations x of I and the unit of their mean x bar are different from that of variance, since variance involves the sum of squares of basically x of I minus x bar. So basically in the calculation of variance, we said that variance, or sigma squared is equal to 1 divided by n by times sigma of x of I minus x bar all squared, as I goes from 1 to n. So over here what you're doing is that you're taking x of I and subtracting from that x bar and raising that to the second power, and then adding all of those terms together as I goes from 1 to n, and then dividing that by the number of observations. So the unit is of course going to change. For example, I would say if x of I denotes, for example, some ages of some people, then sigma squared is going to denote ages raised to the second power, right? So the unit is going to be different. So we find that the units of individual observations x of I and the unit of their mean are different from that of variance, since variance involves the sum of the squares of x of I minus x bar. For this reason, the proper measure of dispersion about the mean, and of course this is naturally calculated as sigma squared. So of course then sigma would be the same unit as basically x of I or x bar. So for this reason, the proper measure of dispersion about the mean of a set of observations is expressed as positive square root of the variance, and it's called the standard deviation. Therefore, the standard deviation usually denoted by I don't know what that letter is. I think that is probably zeta. That is probably zeta. So what they're saying is that basically then the proper measure of dispersion about the mean of a set of observations is expressed as the positive square root of the variance, which is called standard deviation. So standard deviation is called I think that's a misspelling or something, but anyway, sigma is equal to the square root of 1 over n times sigma of x of I minus x bar all squared, as I goes from 1 to n, and that is denoted by sigma, simply sigma, and then basically sigma would have the same unit as x of I or x bar. Now let us take the following example to illustrate the calculation of variance and hence standard deviation of ungrouped data. Okay, so as an example, let's see what we can do with this data here. So the data that I have is okay, so now let's take the variance of this data. The variance of this data over here is the data is basically 6, 8, 10, 12, 14, 10, 12, 14, 16, 18, 18, 20, 22, 20, 22, and 24. Okay, that is my data. And the variance, as we discussed before, the formula for the variance is sigma squared is equal to 1 over n times sigma of x of I minus x bar all squared as I goes from 1 to n. As I goes from 1 to n. So I need to calculate my x bar here. So to calculate x bar, of course, you can take the direct method, you can take the assumed mean method, you can take the step deviation method, but none of them is really important here because you can simply add all of these numbers together and then divide by the number of those numbers. So this is, for example, 46, 66, 76, and you have 76 over here plus 8 is equal to, which is equal to 84. So far we have 84. Now 14 plus 16 is equal to 30, 42, 52, 60, 66. So that's a 0, 1. That's 150. Now 150, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now 150 divided by 10 is equal to 15. That means that your x bar here is equal to 15. Right? And then you can put that in this formula. You can put that in this formula as basically, of course, we need a table here, because I need to calculate x of I minus x bar. So if this is if this over here is x of I, and x of I is basically 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. And then I can calculate x of I minus x bar, and then of course I can square it as well. So x of I minus x bar is going to be 6 minus 15, which is equal to negative 9. Negative 9 squared is equal to 81. 8 minus 15 is equal to negative 7. Negative 7 squared is equal to 49. 10 minus 15 is equal to negative 5. That's positive 25. That's a 9. That's a 1. That's a 1. That's a 9. That's a 25. That's a basically 22 minus 15 is equal to 7, 49. 24 minus 15 is equal to 9 squared is equal to 81. So you get 89, 49, 25, 9, 1, 1, 9, 25, 49, 81, right? Now, sigma x sigma x of I minus x bar whole squared is equal to basically sigma squared is equal to sigma x of I minus x bar whole squared as I goes from 1 to n, which means that you have to add now sigma And of course you need to divide that by n. 1 divided by n, of course. So your n is equal to 10, and all of these numbers added together is basically, you can add them over here, meaning that you can write sigma x of I. You can write sigma x of I minus x bar whole squared as I goes from 1 to n is equal to basically 2 times 81 plus 49 plus 25 and so on and so forth. So you can write 1 plus 9 plus 25 plus 49 plus 81. 1 plus 9 plus 25 plus 49 plus 81. And well, you can add that of course manually, but there must be some, you could actually find some sort of formula for this as well, because these are the squares of all natural of the first n natural numbers. I think that's equal to sigma x of I squared as I goes from 1 to n is equal to, I think, n times n plus 1, n plus 1 times 2n plus 1 over 6, I suppose, if I'm not mistaken. Let me see. Yes, n times n plus 1 times 2n plus 1 over 6. So now if your n is equal to 1, 2, 3, 4, and 5, then sigma x of I, or actually you have to write it as x of I, sigma x of I squared as I goes from 1 to 5 is equal to basically 5 times 6 times 11 divided by 6, and then that's equal to 55. And you can do the same thing over here. So 81 plus 49 is equal to 120, 130, 150, 159, 160, 165, right? Oh, no, that's not that. That is not actually that formula. I'm sorry. No. That is not that formula. I take that back. So adding these numbers together, this is the sum of the squares of the first, basically of the first odd natural numbers, not the first n natural numbers. So you have basically 81 plus 14 is equal to 100, 120, 130, 150, 160, 165. So that's 2 times 165, which is equal to 200, 320, 330, right? So that is 330. So therefore okay, so that is 330, and then you have to divide that by n. So you can write this as 330 divided by 10, which is equal to 33. So that is the variance of your data, meaning that your data goes from 6 to 24. Your data goes from 6 to 24. So let's say that this is basically 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 10, 12, 14, 16, 18, 20, 22, 24. Your data goes from 6 to 24, and the mean of your data was what? Was 15. It was 15 here, right? So the mean of your data is 15. So if the mean of your data is 15, then you can see that basically the variance of your data is 33. That means that, and what that number is, basically you've taken all of your x of i's and found the distance of basically all of those numbers from the mean from 15, from the mean of all of those numbers. Meaning that, for example, you've taken 6, finding the difference between 6 and 15, for example, which is equal to 9, and raising it to the second power. Again, you've taken, for example, 10, and all of your observations are, of course, over here. These are all of your observations. So you've taken all of these observations, taking the distance of all of these observations from the mean of your data, and then raising all of those numbers to the second power, taking the sum of all of those numbers, and then dividing that by the number of observations, which is 10. And that gives you sigma squared, which is, in this case, is equal to 33, which is called variance. Right? So that is basically, for example, variance in this case, and you need to keep this until, and of course, based on variance, now if you take the square root of this whole thing, meaning that the square root of 33, so now your variance became 33. Now sigma, which is called standard deviation, which is basically sigma, and that is actually the square root of sigma squared, right? The square root of sigma squared is equal to the square root of 33, which happens to be 5.74. So 5.74, so that's actually not, that is not the same thing as if you, basically, for example, that if you, for example, take the square root of all of these numbers and then raise all of these numbers to the second power, and then take the square root of all of them and then added them, all of them together, and then divided them by the number of those numbers. It's not the same thing, because I mean, in that process, you would, for example, actually lose the negative sign, for example, something like that, if that was basically your goal. Now, what you have done here is that you have taken all of those distances, raised them to the second power, and then added, and then you've added all of those numbers together. Once you've added all of those numbers together, you've taken the mean of them by dividing them by the total number of the observations. And then you're taking the square root of the mean of those numbers. Okay? So the number would be a little bit different if you somehow raised it to the second power and then took the square root of the same number, but that doesn't really make any sense here really, because I do not know how to basically express what I mean to say, but the important thing here is that standard deviation is actually you can think of that as some value, provided that you've understood this whole process here. Then whatever you get over here is called sigma squared. Now if you take your sigma squared and take the square root of that, that becomes sigma, and that's basically, for example, this number that you get over here. So that's a representation of how basically all of these numbers are scattered around the mean of the data. Okay. So that is that. Now there is something else called the standard deviation of a discrete frequency distribution. So we will talk about that as well. Okay, so we said that basically we came up with the formula for we called it variance, and the variance that we came up with was basically sigma squared was equal to 1 over n sigma of x of I minus x bar whole squared as I goes from 1 to n. That was the formula that we had. Right, that was the formula that we had. Now, if you have the kind of data if you have a discrete frequency distribution table, if you have a discrete frequency distribution table, so then what you have is basically some basically x of i's, and you have some frequency related to those x of i's, meaning that you have some x of i's and you have some f of i's. And so basically it does make sense that suppose that your x's are, for example, x1, x2, x3, and all the way up to x of n, and your frequencies related to these are f of 1, f of 2, f of 3, all the way up to f of n. And so in this case, the variance would be, for example, sigma squared is equal to 1 over n, sigma of f of I times x of I minus x bar all squared, because you're taking all of those distances and then you're squaring them, and then you're basically multiplying the square of those distances by this f of I, so, and then dividing by n, and so that would be basically your variance. And then the standard deviation, and your standard deviation would be basically sigma, which would be equal to the square root of 1 over n sigma f of I times x of I minus x bar all squared as I goes from 1 to n, and that is basically your and that is your standard deviation, where of course n is equal to is equal to sigma f of I as I goes from 1 to n. Now let's take a look at one example using this formula. Let's take a look at one example using this formula. For example, you want to find the variance and standard deviation. Variance and standard deviation related to the following data. So your x of i's are basically the data that you have here. These are your x of i's and these are your f of i's. So you have 4, 8, 11, 17, 20, 24, 17, 20, 24, and 32. And then you have 3, 5, 9, 5, 9, 5, 4, 3, 1. Okay. And then if you basically want to find the variance and the standard deviation. So the formula that I need to use in the case of, for example, variance is sigma squared is equal to 1 over n. So basically sigma of f of I times x of I minus x bar whole squared as I goes from 1 to n, and this would be variance. This would be variance, and sigma would be equal to 1 over the square root of 1 over n times the sigma of f of I times x of I minus x bar whole squared as I goes from 1 to n, and so that would be standard deviation. Standard deviation. And of course, as you can see, you can come up with any other formula that serves you in any particular situation, meaning that you can, it doesn't even have to be a formula. You have a bunch of, for example, observations. You take a look at your observations and you know that, for example, you have to do this particular thing in order to draw some sort of specific conclusion from your data, and you do it. So that would be basically doing something specific manually on your data. For example, if I want to know, suppose that, for example, I have a bunch of observations over here, and there is some observations in my observations, for example, this observation is x1, and I want to know, for example, what is the relationship of all of these observations to this observation in terms of, for example, division or multiplication or whatever that might be the case. And so then, for example, based on this particular situation, I can come up with my own formulas. And of course, that would help me solve a particular type of problem. But then these formulas have become standard in statistics, and now basically all kinds of machines and calculators on the internet and everything else has been kind of equipped with these formulas, meaning that, for example, you can give a bunch of, for example, data to a calculator and then tell it to, for example, calculate variance for you. And using the same set of observations, you tell your calculator to calculate standard deviation for you and any other basically measure for that matter. And of course, when mathematicians and when scientists talk to one another about, for example, some phenomenon or some observations or some specific, for example, topic, they use these words and they use these formulas in order to be able to talk to one another in such a way that they can understand one another. So that's why basically it's important to understand these, and well, just to understand them, and whenever they're appropriate in some specific case, of course you can use them. Now, over here, basically in order to calculate the variance and standard deviation related to this data, you can see that I need, first of all, I need X bar. So I need to calculate my X bar. So I write my data over here in the form of a table, and so I call this, for example, X of I, and I write here my F of I, and well, the data is over here in front of me, so I put this, bring this down so I can write my data in vertical form. And so, for example, my X of I's were 4, 8, 11, 17, 20, and I have 24 and 32. And F of I over here was basically 3595, 395, 3595, 431. And then I need to calculate X bar. So X bar, I can calculate it as, for example, X bar is equal to sigma F of I X of I over sigma F of I, right? This is the direct method. Now, in order to calculate X bar, I have to multiply all of these numbers together, which doesn't seem to be anything impossible. So I just simply calculate, or I can simply make it simpler by for example, by using the other method, which is what is it? The other method. So X of I is equal to, for example, A plus sigma F of I D of I over sigma F of I. This is called the assumed mean method. So I take this 17 as the assumed mean of the data, and then over here I can write, for example, D of I as X of I minus A, and write this as, for example, this is X of I minus A, so 14 minus 17 is 4 minus 17 is equal to negative 13, and 8 minus 17 is equal to negative 9. 11 minus 17 is equal to 17 minus 11 is equal to 6, negative 6, and over here I have 8 minus 17, so 17 minus 8 is equal to, if that's a 17, 9 plus 8 is equal to, that's correct. Here you have a 0, 20 minus 17 is equal to 3, 24 minus 17 is equal to 7, and 32 minus 17 is equal to 15, I suppose. 15. So 32 minus 17 is equal to 15, right? So so then what I have here now is D of I, and you can see that D of I have no class size here or anything, so I cannot make these numbers smaller in any way. For example, there is no such number where basically that I can find that all of these numbers are divisible by. This is a 13, this is a 9, a 6, is 3, a 7, a 15. So it's not possible to do that. So now f of I times d of I, f of I times d of I, which is what I have over here, is, for example, 3 times 13 is negative 39. That's negative 4. What is that? Negative 39. 5 times 9 is equal to 45. 9 times 6 is equal to 54. That's a 0. That's a 12. That's a 21. That's a 15. Better than those numbers. And I took my A as 17. So I can calculate my x bar as A, which is, well, 17 over here, plus sigma f of I d of I. So I can calculate my sigma f of I d of I here. Sigma f of I d of I is equal to, well, 15 plus 21 is equal to 36, 46, 48. And then over here you have 39 plus 40, 79. 79 and plus 5 is equal to 84. And then you have 54 there. You have a 54 there. 70, 84. Let me see. 39 plus 45 is equal to 14. And that's 84. 84 plus 54. So this is a positive number. And that's an 8 and 138, negative 138. So you have 138 minus 48 with a negative sign. 0, 13, so that's negative 90. That's negative 90. And I think, let's see if I didn't make any mistakes here. 15 plus 21 plus 12 minus 54 minus 45 minus 39, negative 90, correct. So sigma f of I d of I is equal to negative 90, and sigma f of I is equal to this thing over here. Sigma f of I is equal to 8 plus 9 is equal to 17. 17 plus 9 is equal to 26. 26 plus 4 is equal to 30. Is equal to 30. And 90 divided by 30 is equal to 3, so that this whole thing goes to negative 3. 17 minus 3 is equal to 14. So your x bar is equal to 14. Your x bar is equal to 14. Okay, your x bar is equal to 4. It doesn't really matter what sort of method you use. It's important to find the mean of your data. Now, what I need over here is basically, now I want to find variance. I want to find variance, and variance is basically 1 over n, and this n is sigma f of I. So first I need to calculate x of I minus x bar whole squared. X of I minus x bar whole squared. So x of I minus x bar whole squared, x bar is equal to 14. X bar is equal to 14. So 4 minus 14 is equal to negative 10. Negative 10 squared is equal to 100. Right? Is equal to 100. Then you have 8 minus 14, which is equal to negative 6. 6 squared is equal to 36. Then you have 11 minus 14 is equal to negative 3, so that's squared is 9. 17 minus 14 squared is equal to 3, squared is equal to 9. Then you have 20 minus 14 is equal to 6, 36. 24 minus 14 is equal to 10, squared is equal to 100. And 32 minus 14 is equal to 2, 12, 8. So 18 squared is equal to, I don't know, 18 squared 64, 6, 14, 0, 18, 4, 12, and 324. So 18 squared is equal to 324. 324. So that is that. Now, if I calculate, now I need to calculate f of I times this expression. So I calculate f of I times x of I minus x bar all squared. Now f of I times 3 times 100 is equal to 300, 5 times 36 is equal to 150, and 30, 180, 9 times 9 is equal to 81, 5 times 9 is equal to 45, 4 times 36 is equal to 120, and then 24, 144 is equal to 144. 3 times 100 is equal to 300, and 1 times 324 is 324. Now I need to calculate sigma f of I times this whole expression. So then I can write sigma f of I times x of I minus x bar whole squared is equal to the sum of all of these numbers. This is 480. This is 480, and this is 126. 126. This is 444, and this is 324. So 126, I suppose, right? 126. So you have 8 plus 6 is equal to 14, 1, 9, 11, 11 plus 6 is equal to 17, 1, 5, 6, 10, 13, 1374. 1374. And I know that my variance, is equal to sigma squared, which is equal to 1 over n, the sigma of f of I times x of I minus x bar whole squared as I goes from 1 to n. So basically sigma f of I times x of I minus x bar whole squared is equal to this number, and I have to divide it by n, which is sigma f of I, which is 30. So I have to write this as 1374 divided by 30. If I divide this by 2, 1374 by 30 divided by 2, it'll get 15 divided by 2, it'll get 500, 150, and 35, 37, you get 7, 8, 6, 687, 687, and 687 divided by 15 is equal to 550, 75, 4 times 15 is equal to 60, and you have an 8 remainder, 87, 5 is 50, 75, 5 times 15, 7, 6 times 15 is equal to 90, so 5 times is 75, 2, 1, and then 0, I'm sorry, no, there is no 0 there, I'm sorry. And then you have 10 times 150 is 10 times 15 is equal to 150, 9 times is 90, and 430, and 8 times is 80, and 40, 120. So 8 times would be 120 and 0. So that's 45.8. That is 45.8. So that means that your variance is 45.8. And also you can calculate your standard deviation. Your standard deviation, which is equal to the square root of, well, sigma squared, which is equal to sigma, right? Which is the same thing as the square root of 45.8. And the square root of 45.8, if you want, if sometimes you need to take the square root of some number without a calculator, it's easy, but you need to know how to do it. It's actually, it's like the division algorithm for square roots. I'll show you how to do that. Okay, so now to take the square root of, for example, 45.8. I hope that I still remember that. So you have 45.8. And you want to take the square root of it. So you write it in this form. You have to basically create this sort of table for it, or these two perpendicular lines. And then you have to basically group the number that which you want to take the square root of into groups of 2 digits from the left. So you start from the left, the far left side of the number, and start basically grouping your number into groups of 2 digits. So over here, for example, you get only 1 digit. So then, for example, over here, what you can write is, for example, you need to write some number over here whose square is less than or equal to 45, which is basically, for example, 7 would be 49, 6 would be 36. And then you can subtract this number, and then you can subtract this number from this number. 36 minus 45 is equal to 9, and then you can bring down the next group, which normally would be basically 2 digits. Right now I have only 1 digit. Now of course when you get to your decimal point, you have to put your decimal point over here. So then I don't really remember the rest of the procedure. Let me see what that was. Okay, so it seems that what I said here was actually wrong, because I used to do this a long time ago and I haven't done it ever since. So, but not entirely wrong, but just one single step. 45.8. You want to find the square root of this number. Now, the square root of this number, you need to experiment with this, because I've never actually taken the square root of a decimal number, but let's see how that goes. Let's say that you want to take the square root of, now in order to make things simpler, what you would usually do, for example, if you had the square root of 458, you would have to group these digits into groups of 2, starting from the ones digit and not from the left. I said from the left, which is wrong. You have to group them into groups of 2 digits from the right. And then what you would do is that you would just simply draw some sort of table over here with these 2 perpendicular lines, and then you would need to start with the leftmost digit. And for example, 4 is already a perfect square, so I can write 2 times 2 is equal to 4, and I can subtract and I'll get a 0 over here. Then what I need to do Now I can, of course, bring down this 58 down here, and I think the decimal point is going to work out for us as well. So so then I have 58 over here, and I need to, of course, proceed with the procedure. So what I need to do is that I get this 2 over here and add itself to it to get a 4, right? Now, what I need to do is that I will leave a digit over here, and the same digit I have to write it over here as well, in such a way that, for example, if I can write any digit over here between 0 to 9. So, for example, if I write 4 times 4, and then the next digit 0, I would have to multiply it by the same digit here, and then whatever that was, I would write it as, for example, 0, and then this number I would subtract from 58. Meaning that, of course, this was not a good example, meaning that, let's say that I took my 4 and I write a 1 over here, and then again I would have to multiply it by the same number 1, and then that would give me a 41, and then I would basically subtract 41 from this number. But your goal is to get as close to this number as possible, or possibly the number itself. So, for example, I could go for probably 49 times 9 is equal. No. I couldn't do that. So as you can see, if I go over 1, I would get 42 times 2, which would be 84, which would be larger than this number. So I have to stick with 1. So I write this 41 over here. And then the 1 over here as well, right? And then 1 times 41 is equal to 41. If you subtract, you will get, well, a 1 over here and a 7 over here. You get 17 remainder. Now what you need to do is of course, I suppose you normally, let me see what he has done over here. 124 plus 4. So again, what you need to do is basically, I need some digits over here, because I need some digits over here to bring down. But this time what I need to do is that I suppose I would put the decimal point over here and 2 digits, because you cannot work with 1 digits when you're working with square roots, I suppose. Let's see how that works out. And then I bring down these 2 digits down here. And then again, like the previous step that I added 2 to itself, I have to add 41. I have to take 41 and add the same digit to it, meaning 41 plus 1 is equal to 42. And another digit over here, another digit over here. Again, you want to put some number over here to get, and of course you need to put the decimal point over here as well, and this digit of course comes over here, right? And then you, for example, if you go for 425 times 5, you would get it something around 2000, which is larger than this number. 424 times 4 is equal to something around 1600, and that's 96. 1696. That's close enough. That's 4 times 4 is equal to 16, 1, 9, and then 16. So I put a 4 over here and a 4 over here. 4 times 424 is 1696. 1696. And 1700 minus 1696 is equal to a 4. And then again, I could go for another 2 digits, and I would get a 0 over here, and then so on and so forth. And of course, 458 is not a perfect square, so you will never get a 0 over here, but you can just keep going and calculate more decimal places here. But I think if I actually try this thing over here, I would get the square root of 458. I would get it as 21.4. As you can see, it does actually work, and it's a valuable technique. It is a valuable technique that you can use in order to find the square root of any number. Otherwise, you would be limited to calculators. So before calculators were invented, people had to come up with techniques to do things on their own, because mathematicians had to do their job, and they have come up with this technique. This technique does not exist in I have kind of gone over all of the, as far as mathematics is concerned, I have gone over basically all of the education systems of the whole world, like the US, and in Asia only India. I have had basically, I did basic schooling in Iran. Such a thing was really not there, never. I suppose, I'm not really sure, but I think I would say that with probably 70-80% certainty, and that's based also on the fact that if you search for this on YouTube, this kind of technique is put on YouTube only by Indians, meaning that only Indians know about this technique, because naturally, because they have learned this in school. Otherwise, by other, you cannot find a video containing this technique by a non-Indian on YouTube. Okay. So anyway, this is such a clever technique to find the square root of any number, and you can use it for your numbers. So for example, for 45.8, you would get 2.114, I suppose. You would get 2.14. 45.8, for example. The square root of 45.8. You would get, oh, sorry. No, you would get actually something else. 45.8. You wouldn't get 45.8, or you would get a completely different thing. Okay, so now let's do 45.8. Let's see how we can do that. Let's see how we can do that. So now if you want to find the square root of 45.8, I think naturally what you would do is that you would, let's see how we can do it. So if I group them this way from the right, then again I will come up with, which is not really possible. So what I'm going to do is not group them this way. I'm going to put a 0 over here and then group them this way. That must be possible and allowed. There is nothing wrong with this operation. So for example 45, and that agrees with the result that I got from the calculator as well. So for example, you want a perfect square less than or equal to 45, which is 36. 36 is equal to 6 squared. So I write a 6 over here and a 6 over here, and 6 times 6 is equal to 36. If I subtract, I will get 9. Now I can simply put my decimal point over here. You probably always want to somehow group your numbers in such a way that your decimal point is not trapped between any numbers or between any groups or in any groups basically. And then you can bring down this group, which is 80. Now, once you bring down that group, you want to take 6 and add itself to it, meaning that you will get a 12. And then 1 digit here, and you will get a 1 digit over here. So if I write 120, for example, 5 times 5, I will get 5, 2, 10, 12, 1, 625. 127 times 7, 49, 4, 14, 18, 1, and 889. It's very close. 128 times 8, 64. This is not possible, I suppose. 16 plus 6 is equal to 22, 2, and 1024. So 127 times 7, 127 times 7 is equal to 889. 127 times 7 is equal to 889. Subtract 8, 18, 17, and 10. You get a 1 over here, 9 over here, and 0. Then again, you can put 2 zeros over here as a group and bring it down here. So, of course, I wouldn't probably proceed, but just to make sure that we understand the procedure. So now you want to take 127 and add 7 to it. You will get 14, 1, 3, and 134. 134, 1 more digit here, 1 more digit here. And now what you want to do is that you want to take 134, for example, multiplied by, I don't know, 4, 5, 6, 7, probably 7 times 300 is 2100, so around 7, I suppose. 1, 3, 4, 7 times 7, let's see what we get. 49, 4, 28, 28 plus 4 is equal to 32, 3, 21, 21, 24, 2, and 7, 9,429. So which is not possible. So we go for 6. 134, 6 times 6, you get 36, 3, 24, 27, 2, 18 plus 2 is equal to 22, and 8,076. So we will get, which is correct, 6 and 6 over here, and you get 8,076. 8,076 subtract, you will get 8 over here, you will get 10 over here, 10, 9, and a 10 over here. You get a 4, a 2, a, no, sorry. This was not correct. So I don't need to break this down. I make this a 0, make this a 9 and a 10. So that's a 4, that's a 2, that's a 0, that's a 1. That's a 1. 1024, right? Now what I need to do again the same story, meaning that I take basically 136, 4 and 1346 and add 6 to it. I get 12, 1, 5, 3, 1, 3, 5, 2. So I write 1, 3, 5, 2 here, and another. Oh, okay, so I need another 2 digits. Another 2 digits, bring them down, put them over here. And now I need to put some digit over here. For example, that's 102,000. So if you go for, basically, if I put any digit here, that becomes, for example, 13,000 times, for example, 5 would be around 50,000. And 5 times 3,000 would be 55,000. something around 7, I suppose. 1352, 7 times 7. That's a 49, 4. 14 plus 4 is equal to 18, 1. 27 times 5 is equal to 35, 36, 3. 7 times 3 is equal to 21, 24, 2. And 7, 9. 94,689. And I suppose you cannot go any further than that, meaning that if you go 1, 3, 5, 2, for example, 8 times 8, you would get 108,224, which is larger than this number. So I go for a 7 and a 7 over here, and I will get 94,689. And then you need to, of course, do the subtraction. You get some numbers here, and again you can just keep doing the same thing. So far I got 6.767. 6.767. And if you take a look at the calculator, it gave me exactly the same number, 6.7675697262755. And of course the number has been rounded to so many decimal places, otherwise the number is not a perfect square. It would keep just going and going. So the number over here is I rounded to 6.768. 768. And that's how you find the square root of any number without using a calculator. So that means that in the case of this example, that was example number 9, your variance becomes 45.8, and your standard deviation is 6.77. And that's basically that. So I'm going to end this video here, and then in the next video we have the standard deviation of a continuous frequency distribution, which we will talk about in the next video. I'll see you in the next video.